Have you ever wondered what lies beyond the planets of our solar system? Beyond Neptune, a fascinating world of mysterious and lesser-known celestial bodies called dwarf planets awaits exploration. How are these worlds different from planets, and why do they captivate astronomers worldwide? Join us as we embark on an incredible journey to uncover the secrets of the dwarf planets in our solar system and explore their unique features and discoveries. Pluto, the trailblazer of dwarf planets. Pluto was the 9th planet of the solar system until 2006, when its reclassification sparked global debates. This icy world, located in the Kuiper Belt, is a fascinating dwarf planet that orbits the Sun over 248 Earth years. Despite being demoted, Pluto remains a captivating celestial body that continues to reveal secrets about our solar system. At 2,377 kilometers in diameter, Pluto is roughly 2/3 the size of Earth's moon. Its surface is a frozen expanse of nitrogen, methane, and carbon monoxide ice, with vast plains like Sputnik Planitia and towering ice mountains. Pluto also boasts a surprisingly dynamic atmosphere that expands and contracts with its elliptical orbit, showcasing how even the coldest worlds can exhibit complex weather patterns. Pluto's moon system adds another layer of intrigue. It has 5 known moons, with Charon being the largest and most remarkable. Charon's size, half that of Pluto, creates a unique relationship between the two, as they orbit a shared gravitational point. This binary system offers insights into how celestial bodies can evolve together in isolated regions of space. NASA's New Horizons mission, which flew by Pluto in 2015, revolutionized our understanding of this dwarf planet. The spacecraft sent back stunning images and data, revealing unexpected geological activity and potential subsurface oceans. These findings hinted that Pluto may harbor conditions suitable for some form of life, redefining what is possible in extreme environments. Pluto's story is far from over. As one of the most well-studied dwarf planets, it serves as a window into the mysteries of the outer solar system, demonstrating that even small celestial bodies can have monumental significance. Ceres, the smallest giant in the asteroid belt. Ceres stands out as the only dwarf planet located in the asteroid belt between Mars and Jupiter. Discovered in 1801, Ceres was once considered a planet before being classified as an asteroid, and finally as a dwarf planet in 2006. This unique classification underscores its importance in bridging our understanding of planetary and asteroid characteristics. With a diameter of about 940 kilometers, Ceres is the smallest recognized dwarf planet but holds massive scientific interest. Its surface is a mix of rock and ice, punctuated by bright spots like those in the Ocketer crater. These spots are deposits of sodium carbonate, a salt left behind by water activity. Such discoveries suggest that Ceres may once have had a subsurface ocean, and remnants of liquid water could still exist today. The Dawn spacecraft, which orbited Ceres from 2015 to 2018, revealed surprising geological features, including cryovolcanoes. Ahuna Mons, for example, is a towering ice volcano that indicates Ceres may still be geologically active. The presence of organic compounds on its surface also raises intriguing questions about the potential for prebiotic chemistry. Ceres' location in the asteroid belt makes it a unique laboratory for studying the building blocks of planets. Scientists believe it formed early in the solar system's history, preserving ancient materials that can provide clues about the conditions during its formation. As missions to Ceres continue to be proposed, this small world holds immense promise for unraveling the mysteries of planetary formation and the potential for life beyond Earth. Ceres is a reminder that size is no limitation when it comes to cosmic significance. Haumea, the peculiar oval world. Haumea is one of the most unusual dwarf planets, recognized not only for its elongated shape but also for its rapid rotation. This celestial oddity resides in the Kuiper Belt and is named after the Hawaiian goddess of fertility and childbirth. Its unique characteristics make it a captivating target for astronomers and planetary scientists. Unlike other dwarf planets, Haumea has a distinctly oblong shape, which is a direct result of its incredibly fast rotation. Completing a spin in just 4 hours, this rapid rotation has stretched Haumea into an oval, a phenomenon rarely seen on such a large scale. This unique shape provides insights into the effects of angular momentum on celestial bodies. Haumea is also notable for its composition. Its surface is largely covered in crystalline water ice, making it one of the brightest objects in the Kuiper belt. This icy exterior hints at past collisions or geological activity that brought fresh ice to the surface. These impacts may also explain Haumea's two small moons, Hi'iaka and Namaka, which orbit it today. Another fascinating feature of Haumea is its ring system. Discovered in 2017, the ring adds to its distinctiveness as one of the few known dwarf planets with this characteristic. The ring likely formed from debris left behind by ancient collisions, showcasing the dynamic processes that shape the Kuiper belt. Haumea's peculiarities continue to challenge and expand our understanding of dwarf planets. Its rapid rotation, unique shape, and icy composition offer a glimpse into the diverse ways that celestial bodies evolve in the distant reaches of the solar system. A Makemake, a frozen world with a fiery name. Makemake, named after the Rapa Nui deity of creation, is another Kuiper belt resident that adds to the diversity of dwarf planets. Its icy surface and distant orbit make it one of the coldest known objects in our solar system, offering an extreme environment for scientific exploration. Measuring about 2/3 the size of Pluto, Makemake is the second brightest object in the Kuiper belt. Its surface reflects a significant amount of sunlight due to a layer of frozen methane, ethane, and possibly nitrogen. These icy compounds contribute to its reddish hue, a feature that distinguishes Makemake from other celestial bodies. Despite its frozen nature, Makemake has shown signs of an atmosphere, albeit a temporary one. Observations suggest that its thin atmosphere forms when it is closest to the sun and freezes when it moves away. This cyclical atmospheric behavior provides clues about the volatile substances present on its surface. Makemake's moon, discovered in 2016, adds to its intrigue. This tiny satellite, informally named MK2, is a dark, rocky body that contrasts with the brightness of Makemake itself. The moon's presence offers scientists an opportunity to measure Makemake's mass and density more accurately, improving our understanding of its internal composition. Makemake's study is still in its early stages, but its unique characteristics make it a compelling target for future missions. As we continue to explore, this icy dwarf planet will likely reveal more about the dynamics and diversity of the outer solar system. Eris, the most distant dwarf planet. Eris, one of the most intriguing dwarf planets, resides in the scattered disk region of our solar system, far beyond Pluto. Its discovery in 2005 played a pivotal role in the reclassification of planets, including the demotion of Pluto to a dwarf planet. Named after the Greek goddess of strife, Eris lives up to its name by challenging our understanding of the outer solar system. Eris is slightly smaller than Pluto, but is the most massive dwarf planet discovered so far. Its high density suggests a composition rich in rock and ice, differentiating it from the gas giants that dominate the outer regions of the solar system. This composition aligns with theories about how icy bodies formed in the cold reaches beyond Neptune. One of the most fascinating features of Eris is its reflective surface, which rivals that of freshly fallen snow. This brightness is due to a thin layer of methane ice, indicating that it may have undergone surface renewal processes in the past. These observations suggest a dynamic history that includes the possibility of cryovolcanism or other geological activity. Eris is accompanied by a small moon named Dysnomia. This moon provides crucial data for calculating Eris's mass and understanding its gravitational interactions. Observations of Dysnomia's orbit allow scientists to estimate the density of Eris, giving insights into its internal structure and formation history. Eris's extreme distance from the Sun places it in one of the most isolated regions of our solar system. This distance poses significant challenges for exploration, but Eris remains a priority for future missions seeking to unlock the secrets of the scattered disk. Its discovery and study continue to reshape our view of the outer reaches of the solar system, demonstrating that there is still much to learn about the worlds beyond Neptune. Sedna, a mystery on the solar system's edge. Sedna, named after the Inuit goddess of the sea, is one of the most enigmatic objects in the solar system. Discovered in 2003, this distant dwarf planet resides in the far reaches of the solar system, in a region known as the Inner Oort cloud. Its extreme orbit and unique characteristics make it a key piece in understanding the early formation of our solar system. Sedna's highly elliptical orbit takes it on a journey that spans thousands of years. At its closest approach, Sedna is still over 76 astronomical units away from the Sun, nearly 3 times farther than Neptune. At its farthest, Sedna ventures nearly 1,000 AU away, a distance that places it among the most isolated objects in the solar system. With a reddish surface, Sedna's color suggests a composition rich in organic compounds. These tholins are likely the result of solar radiation interacting with frozen methane, ethane, and other ices. This composition points to similarities with Kuiper Belt objects, though Sedna's origin and migration remain a mystery. Theories about Sedna's unusual orbit range from gravitational interactions with a passing star to the influence of an as-yet undiscovered 9th planet. Sedna's orbit may also provide clues about the formation of the Oort cloud, a distant shell of icy bodies that surrounds the solar system and serves as a reservoir for comets. Although no missions are currently planned to explore Sedna, its study through telescopes continues to provide valuable insights. As one of the most distant known objects, Sedna represents the solar system's boundary and raises intriguing questions about the forces that shaped its formation billions of years ago. Quaoar, the forgotten jewel of the Kuiper Belt. Quaoar, a lesser-known dwarf planet, quietly orbits within the Kuiper Belt, adding to the complexity and diversity of this icy region. Discovered in 2002, Quaoar was named after a Native American creation deity, reflecting its status as a harbinger of new knowledge about the outer solar system. With a diameter of about 1,100 kilometers, Quaoar is smaller than Pluto, but still one of the largest objects in the Kuiper Belt. Its surface is thought to be a mix of water ice and other frozen compounds, suggesting that it may have had a more geologically active past. Observations of its surface have also detected methane, ethane, and possibly ammonia, pointing to a chemically diverse environment. Quaoar's discovery challenged traditional assumptions about the size and composition of Kuiper Belt objects. Its relatively large size and spherical shape highlighted the potential for even more massive objects in this distant region, sparking a renewed interest in exploring the Kuiper Belt's hidden treasures. One of the most exciting findings about Quaoar is the detection of Waywatt, its tiny moon. This discovery has allowed scientists to study the system's dynamics, providing clues about Quaoar's mass and density. The presence of Waywatt also suggests that collisions and interactions in the Kuiper Belt may have played a significant role in shaping these distant worlds. Although Quaoar remains underexplored, its significance cannot be overstated. It represents a bridge between the well-studied worlds like Pluto and the smaller, more enigmatic objects that populate the Kuiper Belt. As technology advances, Quaoar will undoubtedly remain an essential target for understanding the formation and evolution of the outer solar system. The search for Planet 9 and its dwarf planet clues. The quest for Planet 9, a hypothetical massive world beyond Neptune, has reignited interest in the outer solar system. Dwarf planets like Sedna, Eris, and others may hold critical clues to the existence of this elusive giant, as their orbits hint at the gravitational influence of an unseen force. The theory of Planet 9 arose from observing the unusual orbits of several distant objects, including dwarf planets. These orbits cluster in a way that suggests the presence of a massive, unseen body exerting gravitational pull. If Planet 9 exists, it could be 10 times the mass of Earth and orbit the Sun at a distance of hundreds of astronomical units. The study of dwarf planets is central to this search. Their unique orbits act as breadcrumbs, leading scientists toward the regions where Planet 9 might reside. By tracking these objects with powerful telescopes, astronomers can piece together a map of the gravitational landscape beyond Neptune. While the search for Planet 9 is ongoing, its potential discovery would reshape our understanding of the solar system's architecture. It would also provide context for how dwarf planets form and interact with larger celestial bodies. Dwarf planets could reveal how gravity sculpts the solar system's outer reaches and affects the distribution of smaller objects. Whether or not Planet 9 is ever found, the search highlights the importance of studying dwarf planets. These distant worlds are not only fascinating in their own right, but also serve as critical tools for uncovering the hidden secrets of our solar system. The dwarf planets of our solar system showcase the incredible diversity and complexity of celestial bodies beyond the 8 major planets. From Pluto's icy plains to Haumea's rapid rotation, these worlds invite us to explore and learn more about the cosmos. If you enjoyed this deep dive, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon for updates on our latest content. Until next time, keep reaching for the stars with us.
Have you ever looked up at the night sky and marveled at the celestial dance of the moon and Earth? Lunar eclipses are not just stunning, they're packed with fascinating science, history, and myths that will leave you in awe. From blood moons to cosmic alignments, these events have captured our imagination for centuries. Curious to learn what makes lunar eclipses so special? Join us as we explore 10 cool things about lunar eclipses that will change how you see the night sky. The moon turns red. One of the most iconic features of a lunar eclipse is the dramatic transformation of the moon into a reddish hue, commonly known as a blood moon. This happens during a total lunar eclipse when Earth blocks direct sunlight from reaching the moon. The light that does reach the moon passes through Earth's atmosphere, scattering blue light and leaving red and orange hues to bathe the moon's surface. The intensity of the red color can vary depending on atmospheric conditions, such as volcanic eruptions or wildfires. When there's a lot of dust or particles in the air, the moon can appear a darker, more coppery red. Without such interference, it might glow in a lighter shade of orange. This makes each blood moon unique, a celestial fingerprint of Earth's atmospheric conditions at the time. For centuries, blood moons have sparked myths and legends. Ancient civilizations often saw them as omens of significant events, from the fall of empires to the end of the world. Today we know it's all about physics, but the eerie red glow still captures our imagination. If you've never seen a blood moon in person, you're missing one of nature's most incredible spectacles. Mark your calendars for the next lunar eclipse and prepare to witness the moon in its fiery glory. It's a sight you'll never forget. You can safely watch it without equipment. Unlike solar eclipses, where protective eyewear is essential, lunar eclipses are entirely safe to watch with the naked eye. You can simply step outside and enjoy the celestial show without any special tools. The best part? You don't need to travel far. As long as the eclipse is visible from your location, your backyard can serve as your viewing spot. Telescopes and binoculars can enhance the experience, revealing details of the moon's surface as it transitions through the Earth's shadow. With a bit of magnification, you can see craters and ridges dimming under the Earth's penumbra and umbra. It's like having a front-row seat to a cosmic ballet. Lunar eclipses are also highly accessible. They can be seen from anywhere on the night side of Earth, provided the skies are clear. Unlike solar eclipses, which follow a narrow path of totality, lunar eclipses offer a wide viewing area, making it a more inclusive astronomical event. Gather some friends, set up a few lawn chairs, and enjoy the show. Whether you're using a telescope or just your eyes, the beauty of a lunar eclipse is that it's a spectacular event anyone can enjoy, hassle-free. 3 types of lunar eclipses. Lunar eclipses come in 3 varieties: total, partial, and penumbral, each with its unique features and levels of visibility. A total lunar eclipse is the most dramatic, as Earth's umbra completely covers the moon, creating the iconic blood moon effect. This is the kind of eclipse that often draws skywatchers in droves. A partial lunar eclipse occurs when only a portion of the moon enters Earth's umbra. The result is a moon with a darkened bite, as if a cosmic shadow is slowly consuming it. While less striking than a total eclipse, partial eclipses still provide a fascinating view of celestial mechanics in action. A penumbral lunar eclipse is the most subtle and often goes unnoticed by casual observers. In this case, the moon passes through the Earth's penumbra, causing a faint shadow that slightly dims the moon's brightness. Penumbral eclipses are best appreciated with cameras or telescopes capable of detecting subtle changes in light. Understanding these types enhances your appreciation of how lunar eclipses work. No matter which type graces your skies, each one offers a unique perspective on our planet's interaction with the moon and sun. Lunar eclipses last longer than solar eclipses. If you've ever found yourself wishing an eclipse would last longer, lunar eclipses are your answer. Unlike solar eclipses, which are fleeting and last only a few minutes, lunar eclipses can linger for hours. This extended duration makes them perfect for leisurely viewing and even photography sessions. The reason for this lies in Earth's size. As Earth casts a much larger shadow than the moon, it takes longer for the moon to pass through it. A total lunar eclipse can last up to 1 hour and 40 minutes, while the entire event, including partial phases, can span over 5 hours. This extra time allows skywatchers to enjoy every stage of the eclipse, from the first shadow to the breathtaking blood moon and back again. For photographers, it's an excellent opportunity to capture the transition in stunning detail, creating time-lapse videos or composite images. Whether you're a seasoned stargazer or a curious first-timer, the leisurely pace of a lunar eclipse offers a rare chance to soak in the beauty of the cosmos without feeling rushed. A global phenomenon across cultures. Lunar eclipses have fascinated civilizations for centuries, inspiring myths, legends, and cultural traditions worldwide. In many ancient cultures, eclipses were seen as supernatural events. For example, in Norse mythology, a lunar eclipse was believed to be caused by a wolf named Hati chasing and attempting to devour the moon. Meanwhile, the Incas thought a jaguar was attacking the moon, and they would make loud noises to scare it away. In Chinese folklore, lunar eclipses were linked to the celestial dragon swallowing the moon. Drums and firecrackers were often used to frighten the dragon and save the moon. Similarly, in India, traditional beliefs suggest that eclipses occur when the demon Rahu captures the moon, only to release it after being decapitated by Vishnu. These myths highlight humanity's imaginative attempts to explain celestial events before modern science. Today, lunar eclipses are often celebrated as educational and communal events. From ancient rituals to modern star parties, these phenomena continue to bring people together, transcending cultural boundaries. Planetariums and astronomical societies often host viewing events, using them as opportunities to teach the public about the science of eclipses. What makes these shared experiences even more special is the way they connect us to our ancestors, who also marveled at the moon's transformation. Whether through ancient stories or modern science, the universal wonder of a lunar eclipse reminds us of our place in the cosmos. The moon's role in predicting eclipses. Understanding the lunar cycle is key to predicting when lunar eclipses will occur. The moon orbits Earth every 27.3 days, but eclipses don't happen monthly because of the moon's tilted orbit. Its path is inclined about 5 degrees relative to Earth's orbital plane, meaning it usually passes above or below Earth's shadow. Lunar eclipses only happen during a full moon when the Earth, moon and sun align perfectly in what astronomers call a syzygy. This alignment occurs roughly 2 to 5 times a year, though not all are total eclipses. By studying these cycles, astronomers developed precise methods to forecast eclipses even thousands of years into the future. One fascinating system used historically is the Saros cycle, a period of approximately 18 years, 11 days, and 8 hours. Ancient Babylonians discovered that after this interval, nearly identical lunar and solar eclipses would recur, making it possible to predict future eclipses accurately. Today, space agencies and observatories use advanced tools and software to provide detailed information about upcoming eclipses, including their timing, duration, and visibility. With this knowledge, we can prepare to witness these awe-inspiring events and better understand the celestial mechanics that make them possible. The connection between lunar and solar eclipses. Did you know that lunar and solar eclipses often occur in pairs? When a lunar eclipse takes place, there's a good chance a solar eclipse happened about 2 weeks earlier, or will occur 2 weeks later. This is because the alignment needed for an eclipse usually persists long enough to produce both events within a single eclipse season. Eclipse seasons occur twice a year, lasting about 34 days each. During this time, the moon's orbit intersects Earth's orbital plane, making eclipses possible. When the moon passes through Earth's shadow, a lunar eclipse occurs. Conversely, a solar eclipse happens when the moon casts its shadow on Earth. Despite their shared origin, these two phenomena are dramatically different. Lunar eclipses are visible from anywhere on Earth's night side, while solar eclipses are limited to a narrow path of totality. Additionally, while lunar eclipses are safe to watch with the naked eye, solar eclipses require protective gear. These paired events highlight the interconnectedness of celestial mechanics. Witnessing both a solar and a lunar eclipse within the same season is a unique reminder of the intricate dance between Earth, the moon, and the sun. Lunar eclipses and scientific discoveries. Throughout history, lunar eclipses have played a vital role in advancing scientific knowledge. As early as 300 BCE, the Greek philosopher Aristotle used lunar eclipses to demonstrate that Earth is round. He observed that Earth's shadow on the moon during an eclipse was always circular no matter the moon's position in the sky. Lunar eclipses have also helped astronomers refine their understanding of the moon's distance from Earth. In the 19th century, astronomers timed how long it took for the moon to pass through Earth's shadow, using this information to calculate its orbital speed and distance. These measurements were remarkably accurate, even without modern tools. In recent decades, lunar eclipses have become opportunities for space exploration. Scientists analyze the sunlight refracted through Earth's atmosphere during an eclipse to study its composition. This technique helps researchers understand the conditions that might affect planets with atmospheres similar to Earth's. From ancient discoveries to cutting-edge research, lunar eclipses continue to inspire curiosity and drive scientific exploration. They remind us that even the simplest observations can lead to profound insights about our universe. Eclipses are visible to the naked eye on other worlds. Lunar eclipses are not unique to Earth. Other planets with moons experience similar phenomena, though they might look quite different depending on the planet's atmosphere, the size of its shadow, and the distance to its moon. On Mars, for example, its two small moons, Phobos and Deimos, frequently pass through the planet's shadow, creating mini eclipses known as transits. Because these moons are much smaller than our moon, the events are subtle but still observable from the Martian surface. NASA's rovers have captured these transits, giving us a glimpse of how eclipses look from another planet. Jupiter, with its four largest moons, Io, Europa, Ganymede and Callisto, offers some of the most dramatic eclipses in the solar system. These moons regularly pass through Jupiter's enormous shadow, creating stunning displays visible through telescopes. The interplay between Jupiter's moons and its shadow has also provided valuable data for understanding orbital dynamics. These extraterrestrial eclipses remind us that celestial alignments are a universal phenomenon, offering unique perspectives on planetary systems beyond our own. They are a cosmic connection that ties our sky to the skies of other worlds. The future of lunar eclipse exploration. As technology continues to advance, lunar eclipses are becoming more than just visual spectacles. They're gateways to deeper scientific exploration. In the future, scientists hope to use these events to better understand Earth's atmosphere, climate, and even distant exoplanets. One of the most promising areas of research involves using eclipses to study Earth's atmospheric composition. By analyzing the light refracted through our atmosphere during a lunar eclipse, researchers can detect changes in gases like carbon dioxide, methane, and water vapor. This information helps track climate change and refine models of Earth's atmospheric behavior. Lunar eclipses also provide a testing ground for methods used in the search for habitable planets. By simulating the light conditions seen during an eclipse, scientists can better understand how to detect biosignatures, indicators of life, on exoplanets. The techniques refined during lunar eclipses may one day help identify worlds capable of supporting life. As humanity prepares for lunar exploration and potential colonization, eclipses will play a key role in understanding the moon's environment. These events offer a unique perspective on the Earth-Moon system, paving the way for discoveries that could shape the future of space exploration. And there you have it, 6 more incredible insights into the wonder of lunar eclipses. From inspiring cultural stories to driving groundbreaking science, these celestial events are truly extraordinary. If you enjoyed this cosmic journey, be sure to like, share, and subscribe to InnoVision Tech. Hit the bell icon to stay updated on our latest videos. Until next time, keep exploring the universe with us, one starry night at a time. Did you know that most of the universe is invisible? Scientists believe an elusive force called dark matter shapes galaxies and influences the cosmos in ways we're only beginning to uncover. But what is it, and how do we know it's out there? From its strange properties to the mysteries it holds, dark matter continues to challenge our understanding of reality. Join us as we explore 10 fascinating things you need to know about dark matter, diving deep into the secrets of the unseen universe. Dark matter and the universe's composition. The universe is more mysterious than we ever imagined. While the stars, planets, and galaxies we see fill our night skies, They make up only about 5% of everything in existence. The rest is composed of dark matter and dark energy, which together account for an astonishing 95%. Dark matter alone constitutes roughly 27% of this cosmic makeup. This unseen substance doesn't emit light or energy, making it completely invisible to the naked eye and even to our most advanced telescopes. Despite its elusiveness, dark matter's presence is undeniable. It exerts a gravitational pull on visible matter, preventing galaxies from tearing apart as they spin. Observations of galaxy clusters and gravitational lensing, the bending of light caused by massive objects, offer compelling evidence of its existence. It's the silent architect of cosmic structure, influencing the formation and behavior of galaxies. Dark matter's discovery has been a game-changer in physics and astronomy. Fritz Zwicky first proposed its existence in the 1930s when he observed discrepancies in the Coma cluster's mass. Years later, Vera Rubin's work on galactic rotation curves provided further proof, showing that visible stars alone couldn't account for the gravitational forces at play. This discovery has sparked countless questions. If we can't see it or touch it, what is dark matter made of? Scientists are exploring exotic particles like WIMPs and axions as potential candidates. These investigations are driving groundbreaking research and reshaping our understanding of the universe's fundamental nature. Evidence from galactic rotation. Galaxies are cosmic wonders, but their movement poses a puzzle that only dark matter seems to solve. When astronomers study the rotation of galaxies, they find that the outer stars move just as fast as the inner ones, defying the laws of physics as we understand them. Without a massive amount of unseen matter, these galaxies should have flung themselves apart long ago. Vera Rubin's groundbreaking work in the 1970s provided key insights. She observed that the speed of stars in spiral galaxies didn't decrease with distance from the center, as predicted by Newtonian physics. Instead, the stars on the outskirts moved at nearly the same speed as those near the core. This phenomenon, called the flat rotation curve, pointed directly to the presence of a hidden mass surrounding galaxies. Scientists believe this mass forms a halo of dark matter, enveloping galaxies and holding them together through gravity. Without this invisible structure, the universe as we know it wouldn't exist. Dark matter not only stabilizes galaxies but also plays a critical role in their formation, influencing how stars and clusters come together over billions of years. The evidence for dark matter continues to grow through detailed observations and computer simulations. These models reveal how galaxies evolve, highlighting the essential role dark matter plays in shaping their structure. While the mystery remains unsolved, each discovery brings us closer to understanding this enigmatic force. The bullet cluster and direct proof. One of the most compelling pieces of evidence for dark matter comes from the bullet cluster, a collision of two galaxy clusters that occurred over hundreds of millions of years. This cosmic event has provided astronomers with a rare opportunity to observe the effects of dark matter in action. In this cluster, the visible matter, mostly hot gas, was separated from the dark matter during the collision. Using X-ray observations and gravitational lensing techniques, scientists were able to map the distribution of both. Remarkably, the lensing showed that most of the mass was concentrated in regions where no visible matter was present, aligning instead with the invisible dark matter. The bullet cluster serves as a cosmic laboratory, offering direct proof that dark matter exists and behaves differently from normal matter. Unlike gas and stars, which interact and slow down during collisions, dark matter passes through unimpeded, revealing its unique properties. This discovery has had profound implications for our understanding of the universe. It not only confirms dark matter's existence, but also challenges alternative theories that attempt to explain cosmic phenomena without it. The bullet cluster stands as a striking example of the unseen forces shaping our cosmos. Candidates for dark matter particles. Dark matter remains one of science's greatest mysteries, and uncovering its true nature is a top priority for physicists. Researchers have proposed various candidates for the particles that could make up dark matter, each offering unique possibilities and challenges. One leading contender is the WIMP, or weakly interacting massive particle. These theoretical particles interact only through gravity and the weak nuclear force, making them incredibly difficult to detect. Experiments around the world are searching for these elusive particles, using advanced detectors in underground labs designed to shield against background noise. Another intriguing possibility is the axion, a particle so light and weakly interacting that it's often compared to a ghost. Axions could solve several puzzles in particle physics, including the strong CP problem, while also accounting for dark matter. Innovative experiments are underway to detect these particles using specialized magnetic fields and radio waves. Some scientists are also exploring the idea of sterile neutrinos, a hypothetical type of neutrino that doesn't interact with normal matter. If proven to exist, sterile neutrinos could help explain dark matter's properties and its role in cosmic evolution. While no dark matter particle has been definitively detected, the search is pushing the boundaries of science and technology. Each experiment, whether successful or not, adds to our understanding and brings us closer to unveiling the true nature of the universe. Dark matter and gravitational lensing. One of the most fascinating ways we've detected dark matter is through the phenomenon of gravitational lensing. This effect occurs when massive objects like galaxy clusters bend the light from distant galaxies, acting like a cosmic magnifying glass. Gravitational lensing doesn't just help us see far-off galaxies, it also reveals the presence of hidden mass, dark matter. When astronomers observe lensing, they can calculate the mass of the lensing object based on how much the light bends. Often, the visible matter like stars and gas accounts for only a fraction of the mass required to produce the observed lensing. The rest is attributed to dark matter. This technique has allowed scientists to create detailed maps of dark matter distribution across the universe. What's truly incredible is how gravitational lensing provides a window into the past. The light we see has traveled billions of years, giving us a glimpse of the universe as it was when that light first began its journey. Through this lens we can trace the role of dark matter in forming galaxies and clusters over cosmic history. Gravitational lensing isn't just a tool for studying dark matter, it's also a reminder of the interconnectedness of the cosmos. The unseen mass that warps space and time continues to shape the universe, guiding the paths of light and the evolution of celestial structures. The role of dark matter in cosmic structure formation. The universe we see today, filled with galaxies, stars and planets, wouldn't exist without dark matter. This invisible substance played a crucial role in the formation of cosmic structures after the Big Bang. In the early universe, tiny fluctuations in the density of matter created gravitational wells, and dark matter provided the necessary scaffolding for these structures to grow. Dark matter clumped together under its own gravity, forming vast cosmic webs that span the universe. These webs became the framework for galaxies and clusters to form, as visible matter was pulled into the dense regions created by dark matter. Without this invisible scaffolding, the universe would be a much emptier place. Simulations of the universe's evolution confirm dark matter's central role. When scientists run models with only visible matter, the results don't match the universe we observe today. But when dark matter is included, the simulations align perfectly, reproducing the large-scale structures we see in the cosmos. Understanding dark matter's role in cosmic structure formation not only explains the past but also helps us predict the future. As we map the universe and uncover more about its hidden components, we deepen our appreciation for the forces that have shaped everything we know. Dark matter and its interaction with normal matter. One of the most perplexing aspects of dark matter is how little it interacts with normal matter. While it exerts a gravitational influence, it doesn't emit, absorb, or reflect light, making it invisible and incredibly hard to detect. Scientists believe this non-interaction is key to its stability and longevity in the universe. Unlike normal matter, which interacts through electromagnetic weak and strong nuclear forces, dark matter seems to avoid all these interactions except gravity. This explains why dark matter doesn't clump together to form stars or planets like visible matter does. Instead, it remains distributed in massive halos around galaxies, influencing their rotation and structure. Despite its elusive nature, researchers are using ingenious methods to detect dark matter's subtle interactions. Detectors placed deep underground are searching for faint signals of dark matter particles colliding with atomic nuclei. While results so far have been inconclusive, each experiment refines our understanding and brings us closer to a breakthrough. The lack of direct interaction with normal matter is both a challenge and a clue. It suggests that dark matter could be composed of entirely new particles or forces, expanding the boundaries of physics and opening doors to unexplored realms of science. Theories and models of dark matters. Dark matter has inspired a wide range of theories, each attempting to explain its nature and origins. One of the most popular models involves WIMPs, or weakly interacting massive particles, which could be remnants from the early universe. These particles are predicted by extensions of the standard model of particle physics, such as supersymmetry. Another intriguing theory involves axions, hypothetical particles that could solve long-standing puzzles in quantum physics. Unlike WIMPs, axions are incredibly light and interact even less with normal matter, making them even harder to detect. Despite these challenges, experiments like ADMX are hunting for evidence of their existence. Some researchers propose that dark matter could be composed of primordial black holes, tiny black holes formed shortly after the Big Bang. These objects could mimic the effects of dark matter, though evidence for this theory remains scarce. Other models suggest exotic forms of matter such as sterile neutrinos or even entirely new dimensions of spacetime. Each theory pushes the boundaries of what we know, driving innovation in both science and technology. The search for dark matter isn't just about solving one mystery, it's about uncovering new laws of physics and redefining our understanding of the universe itself. Dark matter and dark energy, the cosmic